All right, so in this video, we're going to talk about how to multiply polynomials. In previous videos, we talked about how to add them and subtract them and so forth. Now we're going to start talking about multiplying. A word before we get started, there are a couple different techniques that people use when multiplying polynomials. Probably the most famous technique is a technique that's known as FOIL. That's probably something you may have used in a previous math class. That is not the technique that I'm going to teach right now. And so I just want to make sure that you understand if you want to use FOIL in our class, you're allowed to use FOIL. But there's a reason I'm going to teach you a different technique. And the reason is because it connects directly to the factoring methods that we're going to learn in the subsequent videos. So over the course of this next week, we're going to learn different ways to factor polynomials. And unfortunately, FOIL doesn't connect very well to many of those methods. And so while FOIL is a great method for multiplying, it's not a very good method when we get to factoring. And since we're going to need to do both, I'm going to show you a different method. Now, if you really love foiling, you're allowed to use that. That's fine. You can always use any valid math method in our class. Okay. And I will make another video that will be optional. You don't have to watch it if you don't want to, but I will make another video that reviews how to use FOIL. So if you really, really want to, you can do that. But I would say as we get started in this unit, of multiplying and factoring polynomials, the method that I'm going to show you today really becomes the key method. And I hope you'll take some time to at least give it a fair try. If it ends up you like FOIL better, that's okay. But at least give this one a fair try. All right, so with that little disclaimer, as we get started, let's take a look at our learning objectives for this video. So in this video, we're going to talk about how to multiply polynomials. We're going to start with just normal distribution multiplying by a monomial. So monomial, you might remember that means the polynomial only has one term in it. Mono means one, only one term in this. And then we're going to talk about how to multiply something that has two terms, binomial. And we're still using distribution. I call it double distribute. Technically, it's still distribution. And you'll see what that looks like. And based on the pattern that you're going to see in these two things, in theory, you should be able to extend this out and multiply polynomials of any size. Obviously, in practice, there's limitations. I'm not going to ask you to multiply a polynomial with 15 terms times a polynomial that has 30 terms. That'd be ridiculous, right? But I certainly could ask you to multiply something with 2 terms times something that has 3 terms or something along those lines. So that's what we're going to get into. And because distribution is the method that we use in all of these situations, there really isn't much theory to talk about. You already know about the concept of distribution. So really, we're just going to get into some examples right away. So with that said, let's take a look at an example where we are multiplying a monomial times a binomial. That's probably the easiest place to start. So here we go. Example number 1. Let's multiply a monomial, okay, something that only has one term. Remember, terms are things that are separated by plus or minus signs. So even though there's 2 things here, there's only one term because there's no plus or minus sign. And we're going to multiply that by x minus 4, okay? Now that has 2 terms, right? Because there's a minus sign. So these are my 2 terms. So this has 2 terms, that's a binomial. This has 1 term, that's a monomial. So this is a monomial times a binomial. And we're going to do that with distribution, okay? And so these are the types of problems we've actually looked at already in our class. You know that you're going to distribute to those 2 terms right there. And so when you do that in the first situation, I've got 2. When I look at my coefficients, this has the sneaky ninja 1. So I've got 2 times 1, which gives me 2. And then for my x's, they have the same base, x times x. So my rule is I'm going to add their exponents, and they have sneaky ninja 1 exponents. So 1 plus 1 gives me 2. So I get a 2x squared from the first piece. When I distribute to the next thing, I have to remember that the sign goes with the term. So this isn't really just a 4, it's a minus 4 times a positive 2. So minus 4 times positive 2 gives me a negative 8. And then there's nothing to multiply the x by, so it just stays there. And that's my answer, 2x squared minus 8x. Okay, so that's the most simple type of polynomial multiplication problem that you're going to see, is a polynomial where one of them is a monomial and the other one is maybe a binomial or something small and simple like that. Let's do one more example that is a monomial times something else. So this time, let's do a monomial times a trinomial. Okay, so you've got the basic idea of distribution down. So why don't you pause the video and try this on your own first, and then resume the video to see if your work matches mine. Okay, so hopefully you've tried this. You should have started by distributing this into all three terms. So I'm going to get a 3x squared times a 4x squared. That would be the first thing I do. So 3 times 4 gives me 12. They have the same base, so I'm going to add my exponents. 2 plus 2 gives me x to the 4th. Okay, now I'm going to distribute that to the middle term here. So a 3x squared times an x. I look at my coefficients. This has a sneaky ninja 1. So 3 times 1. And it's a positive 1. So positive 3 times positive 1 is going to give me a positive 3. 3 times 1 is 3. And then x squared times x, they have the same base. So I'm going to add my exponents. 2 plus 1 gives me 3 for my exponent. Okay, moving on to my last term, I'm going to distribute here. So I've got a positive 3 times a minus 2. That's going to be negative 6. And then x squared, there's no x's over here. So I'm just going to have the x squared. It's not going to combine with anything. And that becomes my answer. Okay, so this is multiplying with a monomial. And it's really just basic distribution like you've been doing for several years. Okay, now let's talk about distributing or multiplying with a binomial. So here's example 3. So now we're going to take x, let's just make it x to the first. Okay, so x plus 3, and let's multiply that by 2x minus 1. Okay, so this is the situation. When you see the problem, you might recognize this as from years past where a problem where you do FOIL, right? FOIL stands for first, outside, inside, last. And like I said, you're welcome to use FOIL, but FOIL won't help us much when we start factoring. And so I'm going to ask you to watch this method that I'm going to use. This method, I call it double distribute just so that I give it a name. It technically is just the distributive property. That's all it is. Okay, it's just the distributive property, but I call it double distribute, and you'll see why in just a second. Okay, so what I'm going to do is treat it like this problem right here. First, I'm going to take whatever's on the outside, and I'm going to distribute it to the two things on the inside. Okay, so on the outside is a grouping, a set of terms, x plus 3. And I'm going to take that whole group, that whole thing, and distribute it into both of those. Okay, so what is that going to look like when I do that? Well, I'm going to end up with this x plus 3, and then times the 2x. Now that's exactly the same as like the problem that we just did. I have just a monomial that I can distribute. Okay, I'm also going to distribute this to the negative 1. So I'm going to end up with an x plus 3 times a negative 1. Okay, so I'm going to do that. Now, what I always do is I just always put a plus sign in the middle. The reason why I do that is because I think of this not as being a minus 1, but as plus negative 1. So the negative goes with the 1 here, and the plus sign just stays in the middle. It keeps my signs nice and simple. I just always put a plus sign in the middle. So that's my first distribute. I just distributed the whole thing. Notice when I did that step, I really didn't do any math at all. I just rewrote it is all I did. And now I'm going to distribute again. So I'm going to take this thing and distribute that. And now that's exactly like the problem that we just got done doing. So I've got a 2x times an x. That's going to give me a 2x squared because I'm going to add my exponents. 2x times 3. That's going to give me a 6x. I still have this plus sign in the middle. That's not going to go away. That's still there. And now I'm going to distribute this negative 1. So negative 1 times x is a negative 1x, but I can just make that minus x, keep the sneaky ninja. Negative 1 times 3 is a minus 3. And now what I'm going to do is combine my like terms, which I only have one set of like terms. It's those right there. So I have the first thing, nothing else combines with that. My like terms to combine to give me a 5x, and then I have a minus 3 at the end. And that becomes my answer. Notice I did put my answer in standard form. I've done that for all of these. I forgot to mention that on these two. But from the material that we learned last week, remember standard form is all of the like terms have been combined, and my exponents go in order from the biggest to the smallest. Okay, so that should be standard for all your answers. You've got them all in standard form. Okay, so this is the idea of doing double distribute. Now, one other thing that I'll mention again, just for the people who really, really like FOIL, they remember FOIL, they love FOIL, FOIL is their jive. Notice that I'm getting the same thing. First, outside, inside, and last. I'm getting the same thing, I'm just getting them in a different order. Okay, so it really is the same amount of work as doing FOIL. It really is just a different way of thinking it. Okay, that's all it is. And like I said, the reason I like this method better is because this method is going to connect to the way that we're going to learn how to factor. Whereas FOIL doesn't really connect to anything. It's just a little shortcut that we use when we multiply. All right, let's wrap up with one more type of problem where we could use double distribute. So let's say I have a 2x minus 3, and I'm going to multiply that by an x plus 4. Okay, 2x minus 3 times an x plus 4. All right, so again, I want to strongly encourage you to try this with my method of double distribute or distributing twice. Pause the video right now and give it a try, and let's see if we don't end up with the same answer. Okay, so hopefully you've tried that, and hopefully you started by taking the whole thing on the outside and multiplying it by the two things, or to the two things on the inside. Just a normal regular distribute. It just looks a little funky because we're doing the distribute with this whole great big chunk. So it looks a little funky, but it's still a distribute. I've got the plus sign right here, so it's going to stay there. And now I'm going to distribute this. So a 2x minus 3 times the 4. So there's my first distribute. I just take that whole big chunk and distribute it to the two terms on the inside. And now I'm going to distribute again. So I've got a 2x times an x, that's a 2x squared. Negative 3 times x is negative 3x. Here, when I distribute, a 4 times 2x is 8x. And when I distribute to this, a 4 times negative 3 is negative 12. Now I can combine my like terms. These are going to combine to give me a 5x. Everything else doesn't combine, so that just stays there. I've got a 2x squared, my 5x was positive, and then I've got a minus 12 at the end. And there's my answer. Okay, so this is the method that I'm going to recommend that you try. Now, again, you're allowed to use FOIL if you want, but I'm asking you to give this an honest college try. Do some of your homework problems using this method. Give yourself a chance to get used to it, because here's the thing. The first time you try this, you're going to automatically like FOIL better just simply because of the fact that you're already used to FOIL. Okay, so it's going to take you a couple of tries with this to reach the point that you feel like you're comfortable with it. And I'm going to ask you to try and do at least half of your homework problems tonight using this method of double distribute. And then that way, that gives you time to actually give it an honest try and get comfortable with it. And then also, what the other thing it'll do is when we get into the factoring methods later this week, it'll make sure that you're familiar with that, because like I said, we're going to use that to help us factor later. Okay, so I think I've beat that horse enough tonight. Let's finish to our last learning objective, which is to be able to extend this out to any size polynomial. So what I'm going to do is I'm just going to get one size bigger. I'm going to take a binomial and multiply it by a trinomial. Okay, so just one size bigger, not getting crazy, just one size bigger. And you know what? Actually, I want to make sure I'm distributing something with a negative, because I don't think we've done that yet in this video. So I'm going to change this to be an x minus 3 instead. So I apologize for that. But we definitely want to make sure we have practice distributing a negative sign. So let's make that an x minus 3. And now let's do this. And again, I'm going to use it with the method of double distribute, because notice on this, FOIL doesn't work at all. Okay, that's one of the things that is a downside to FOIL. It's a great shortcut when you have this kind of a problem, but it doesn't work with any other kind of problem. But my double distribute method, it works for every kind of problem. So what I'm going to do is I'm going to use double distribute. I'm going to take this whole chunk at the front, and I'm going to distribute that in to all the terms in that trinomial. So that's going to give me an x minus 3 times this first term. Then I'm going to have an x minus 3 times that middle term. And then I'm going to have an x minus 3 times that last term. And remember, I think of all of these as being plus signs. So I think of this as like a plus a negative 4. So it just lets me put a plus in between every one of those. Okay, and that's what the way I handle it. I just make everything plus. It keeps it nice and simple. So there's my first distribute. And now I'm going to go through and distribute these back for my second, or my double distribute. Okay, so here, 2x squared times x, that's going to give me a 2x cubed. 2x squared times negative 3 is going to give me a negative 6x squared. And I've got a plus sign. X times x is x squared. X times negative 3 is negative 3x. Then I've got a plus sign. Negative 4 times x is a negative 4x. And negative 4 times negative 3 is a positive 12. And now I'll go through and I'll combine all of my like terms. This is another thing I like about double distribute is notice that all of my like terms, they're right next to each other. Okay, that almost always happens with double distribute. There's a couple times where it might not, especially when we start getting into larger polynomials. But with the type of polynomials that we'll see in our class, that almost always happens, which is very convenient. So here we go. There's nothing that combines with a 2x cubed. So that's going to stay there. For my x squareds, I've got a negative 6 and a positive 1. So that combines to give me negative 5x squared. For my x's, I've got a negative 3 and a negative 4. Those will combine to be negative 7. And then there's nothing that combines with my constant. So I get a plus 12 at the end. And there's my final answer. Okay, so again, this is the method that I prefer, double distribute. And the reason I like it is because it works for everything. FOIL is somewhat inconvenient in my opinion because it only works for these special problems. But on these special problems, if you want to use FOIL, you can. I am going to ask though, again, one last time, give double distribute a fair try as you're working through the homework problems tonight. So I think we've hit all of those learning objectives. Thanks for watching this video. Have a good one.